Today we will discuss refraction of light through a glass prism. Okay, so let's see here. This is the prism. This PQ are the prism I have taken. This is the front view, and PQ and PR are the refracting surface, and let this CD striking to the refracting surface PQ. And here remember, I am taking the monochromatic light. Monochromatic means a single color light I am taking. Okay, CD, it is a monochromatic light. It is a monochromatic light. Color means light of single color I have taken. Because why it is not polychromatic light I have taken or white light I have taken? Because when it striking to the refracting surface, dispersion will take place, deviation will be there. That is why it is not taken. Okay, now here there will be a perpendicular as usual way, and here it is the rarer surface, this is the denser medium, this is the rarer medium, this is the denser medium, and when it comes to the rarer to denser, it deviates towards the normal. So as a result, what it will be? It will bend. Instead of going in its original direction, it will be its original direction. Instead of that, it is coming nearer to the normal, and we can say towards the base of the prism. When it is striking to the another surface, obviously there will be a perpendicular here, and here this one will be away from the normal. This one will be away from the normal. Okay, so this one it is refracted ray, this one it will be emergent ray. This one it is emergent ray. This one it is refracted ray. Refracted ray, and here we can say this one it is the angle of incidence, this one it is that angle of refraction, here also it can be refraction, and this one will be angle of emergence. Now here let us see how this one, if it is emergent ray, and if there will be no prism there, it could have gone in this direction, isn't it? So let us see that it could have gone in this direction. Let us extend that one, and it goes like this. And if we extend this emergent ray backward direction, what will happen? Let us see. This is that emergent ray I have taken that one in the backward direction. And we have observed that here there is a deviation produced. This deviation is represented by delta. Okay, this is known as angle of deviation. This is angle of deviation. Okay, so this angle of deviation here, it varies depending upon this whatever this angle of incidence, all these things. Now let us see that here this one will be this one it is A. Let us take this one, it is that angle of prism. This one it is angle of prism. Here I have taken angle of incidence, here I have taken angle of emergent, here it is angle of deviation. So let us find out what is the relationship between them. Here relationship between angle of prism A, angle of deviation delta, angle of incident I, and angle of emergent E. Let us see that one. Here what will be the relation between them? Relation is A plus delta is equal to I plus E. The relation is A plus delta equal to I plus its derivation. It is not necessary for us relation only we need, that one is A plus delta equal to I plus D. So keeping this one in mind, we will go for something else. And here we will see now what are the factors on which this angle of deviation produced depends on. This relation between A plus delta means angle of prism plus angle of deviation is equal to the summation of angle of incidence and angle of emergence. Okay, so this is the formula for a derivation, not required. And here let us go for how to find out the deviation. So angle of deviation equal to I plus C minus angle of prism. Now let us see, if we are talking about this angle of deviation, on what factors this angle of deviation produced depends on. One will be that angle of incidence, angle of prism, and refractive index of the material of the prism. What is the material of the prism you have taken? Then wavelength of the light. One important thing, remember, whenever light chapter we are discussing, when we are discussing the factor, this wavelength of light is one of the common factor. Closing your eyes, you can write this wavelength of light as one of the factor in all cases. Experimentally, it is proved that, and experimentally it is seen, when angle of incidence changes, angle of deviation also changes. Let us see this one, some idea we will get. Let this one is the prism and this one it is the incident ray. Obviously this one will be refracted and this one will be emergent ray. If no prism was there, otherwise if we will forward it, okay, let us forward this one, we are changing this, so we are getting this one as delta. Let us, and here we are getting this one, it is the angle of incidence. Let me change this one to show you. Here let us see, here I am adding here, obviously there will be a perpendicular here, and this one it is changing, and when it reaches here, so see that it is going this direction, it is going this direction. This is that angle of deviation we are getting. There is a change in that angle of deviation. Okay, so it is experimentally seen that whenever we are changing angle of incidence, angle of deviation also changes. And this angle of deviation, first of all, it is seen that with increase, here from the graph we can see, when we are increasing that angle of incidence, angle of deviation goes on decreasing and it decreases up to a point, and that situation is known as minimum angle of minimum deviation, angle of minimum deviation. Okay, and after minimum angle of deviation, with increase in that incident angle of incident, angle of deviation also increases. Okay, so what we can write, relation we can write angle of deviation decreases. Here we can write angle of deviation, first of all, okay, decreases with increase in angle of incidence up to, this one is important, up to minimum angle of deviation, up to minimum angle of deviation. After minimum angle of deviation, it increases. It means this angle of deviation, it increases with increase in angle of incidence. So what we can write? Up to, we can write up to minimum angle of deviation, this delta is inversely proportional to I. But after minimum angle of deviation, this delta is directly proportional to I. Okay, so here what we can see from the graph, it is clear. This one it is known as ID curve. This is ID curve. Now let us see that what is minimum angle of deviation. So what is minimum angle of deviation? The angle of incidence for which angle of deviation produced by the prism is minimum is called minimum angle of deviation. So for example, let us see here, I am taking this prism, here it is striking parallel and it moves, after that one it deviates, then here it is like this, we are taking this one will be delta, this one it is I, this one it is E. So let me explain you the angle of incidence for which angle of deviation produced is minimum. Okay, not for all the cases. For any, if except this angle of deviation, if minimum angle of deviation, other way, for example, I am taking, see this graph, this is ID graph. If I am talking about this angle of deviation, for this angle of deviation, what I am getting? I am getting here 1 point, here 1 point. So for one angle of deviation, this angle of incidence, here this one will be one angle of incidence, this one will be another angle of incidence. But for in this case, one and only one particular angle of incidence, prism produces a minimum deviation. But this point, this which is known as delta minimum for us, this one is delta minimum for us, it is only 1. So for this, there will be a particular, if this one is delta minimum, for this delta minimum, there will be a particular angle of incidence. Okay, other cases, except this angle, minimum angle of deviation, other means positions for delta, you will get two such angle of incidence. For example, another point let us take here, if I am talking about this one, for this one will be that angle of incidence. And this one, if it coming, this is also there, and here this is also angle of incidence for you. But for the minimum angle of deviation, this one will be one and only one present here. And this is most important exam point of view. What is that one? This, at this minimum angle of deviation position, at the minimum angle of deviation, at the angle of minimum deviation. Okay, so see this one, this is another interesting. If I consider this is the, okay, if it strikes, this one will be perpendicular and this refracted ray will be parallel to the base of the prism. This one will be parallel to the base of the prism. Okay, and angle I will be equal to angle E. And these two refracting R1, let it be R2. These two will be equal. So, at the minimum angle of deviation case, what we can write? Angle I is equal to angle E. First point. Second point, this one will be refracted ray. Refracted ray is parallel to the parallel to the base of the prism, to the base of the prism, and here what we can say, R1 is equal to R2. R1 is equal to R2. So at this minimum, so remember this one, this is board question, and if question comes, draw a refraction through a prism and show this minimum angle of, at the minimum angle of deviation position. So what you will draw? You will draw this one, you will show this ray will be parallel to the base of the prism, and you have to write all these things. Many times this question comes, pre-board and this board also. Now, if I am getting at the minimum angle of deviation condition, delta minimum, at the point delta minimum, I is equal to E. Okay, so what we had this, A plus delta is equal to I plus E. This is the formula we had. If I is equal to E, I can take 2I here, A plus delta. So delta equal to here 2I minus A. This one can be the formula. Otherwise, if you want to find out what is the angle of incidence, you can take A plus delta by 2. This also can be another formula. This is angle of prism. This angle of prism, deviation depend upon this angle of prism. So here with angle of deviation increases with the increase in the angle of the prism. So what we can say here, angle deviation, this angle of deviation is directly proportional to the prism. For example, we can take if it is equilateral prism. Example, equilateral prism. Equilateral prism. So A equal to 60 degree, and here we can say prism. A equal to 45 degree. Okay, so in both the cases, as this one equal to 60 degree is more, so what we can say, the in equilateral prism produces greater deviation than that of this prism. Okay, so here as a 60 degree, this one is a 40 degree, this one will produce more deviation. Angle of deviation will be more. Third factor is refractive index of the prism material. Okay, so this one it is mu, and here this angle of deviation increases with increase in the refractive index of the prism material. So what we can write, delta directly proportional to the refractive index. Okay, so we can write higher the refractive index, higher the refractive index, higher is the, more is the deviation, more is the deviation produced, and vice versa, Okay, so less the refractive index, less will be the deviation produced. So let us take one interesting example. Let us take two materials. One will be a flint glass, another one will be the crown glass. So here this one will be flint glass, another one it is crown glass. Okay, and this flint glass is the refractive index of this flint glass is more in comparison to the crown glass. So this one it is less. So what it will be? Deviation. So we can write here mu of flint glass is greater than mu of the crown glass, or refractive index of the crown glass. Okay, so what does it say? It says that this deviation produced in the flint glass, so deviation produced in the flint glass will be more in the deviation produced in the crown glass. Okay, so how to remember this one? So let me give you another interesting thing. How will you remember? Let us see that A, B, C, D, E, F, G, all these things let us write. And let me point out here, C stands for crown glass and F stands for flint glass. If we will give the values to this 1, 2, 3, 4, 5, 6, 7. So this flint glass getting this number 6 and crown glass getting this number 3. So we can say that one, because while doing this one it is practically confusing for the students. So we can get here this one, mu flint is greater than mu crown. So deviation produced in the flint glass will be more than deviation produced in the crown glass due to this refraction. Next is wavelength of light. Here let us take two extremes. So here one will be red, another one will be violet. As usually we take these two extremes not to show this deviation or all these properties. So here angle of deviation decreases with increase in that wavelength of light. So this angle of deviation is inversely proportional to the wavelength of light. So let us see here, I have taken, let it be a white light. Then this one it is, I have divided into two extremes, red and violet, let it be. For red color, this is that angle of deviation. For violet color, this is that angle of deviation. See that one here, this one will be for this violet, this one delta and this one delta. So here it clearly shows delta deviation for this violet color will be more than that of this red color of light. Because why? Because a wavelength of violet is less than wavelength of red.